Today we are working on a very important law called Ohm's law, and it is with three parameters: V equals Ri. V is the what you call the voltage potential difference. R is the resistors, and I is the electric current. So let's solve right away the first questions here. What voltage is required to produce a current of 0.62 amperes in a 250 ohms resistor? Now the ohms is the unit for resistor. We can also find it somewhere with the letter omega, capital omega. So that's a straightforward equation of V equals Ri. I is given 0.62 amps. The R is given, this is 250 ohms, so V unit would be in volt. So just multiply 250 multiply by 0.62, and that will give us V equals 155 volts. So this is not very difficult to apply. Just to use the equation. So we have only three parameters. Okay, let's move on. This one here, number 2. A resistor 1, what we call the R1, it has a resistance of 10 ohms, and it carries a current of 3, let's put one decimal place here to keep it a 2 suffix, so 3.0 amps. And then we have a resistor 2, and the resistor 2 has 5.0 ohms, and it carries the a current of 10 amps. So the question is, which resistor has the greater potential difference, which means we compare V1 to V2. So V1 is 10 times 3, which is 30 volt, and V2 would be 5.0 times 10, which is 50 volts. So from here we see that V2 has a higher potential because it's 50 volts compared to 30 volts. Okay, let's move to another questions. So this time we are talking about a battery. So for this time around, I'm gonna draw what you have seen before with the different components parts. So this is the first time we will see a circuit, an electric circuit. So we will draw first an EMF. So I'm going to draw it this way. This is the EMF. So remember that the large plate is positive, the small plate is negative, and we put always a switch. So some switch is represented by the letter K, but you know, when you draw it this way, then you know what is the switch. And this is talking about flashlight, so I'm gonna put just a light here, a lamp, a kind of lamp, and we will connect it to the other side of the batteries on this side, so this way. That's an electric circuit. Now, by definition, in electric circuits, the current is moving out of the batteries from the positive to the negative outside. So we can write it this way, I, and going this way, I, and then going this way. So that means when we turn on the switch here, then the current is moving back through the negative poles. Okay, so the question is, this bulb here, it is that there is a current passing through this bulb, 0.44 amps, and our EMF, or the batteries, has a 1.5 volt. And the question is, number one, what is the charge that passes through the circuit? So remember that from the text we have the time 64 seconds. So from the previous equations, we know that by definition of an electric current is charge divided by charge passing through a portion of wire, or at a certain point of the wire, divided by time. And since the question is about Q, what is Q? So from here we can solve Q equals I times T. So if we replace the I with its numerical values, 0.44 amps, then you multiply by the time, so the time is 64 seconds. And when you do these multiplications, we're gonna find 28, let's say 28 coulombs. 28 coulombs. That's the answer for question number 1. Now, question number 2, determine the work done. I'm going to use a different color. Determine the work done by the batteries. So the work done by the battery is represented by the letter W. That's a work. And the W, the formula is W equals QV. So that's a total charge multiplied by the difference of potential. So we just replace this by their numerical values. So W equals 28, the charge, multiplied by the voltage is 1.5 volt, and that will give us something like 42 watts. So 42 watts is the answer. For this last question, number D, we use the same equation. So I will draw briefly again what is it about. So we have a circuit. This is a flashlight, but I'm going to use again the circuit. We have the battery here, negative, positive, and this is attached to a lamp. So this would be the lamp of the flashlight, and always we put a switch, because we need to have a switch to cut off the current or to turn this on. So again, if we have to draw, for example, the electric current, the direction, it is always going out of the positive charge. So the current I would be in this direction, in this direction, in this direction, in this direction, and this is closing to the negative sign. So we have I equals 0.78 amps, and it says that this is used to pass through this light here for a given time of 25 minutes. So if you need to convert the 25 minutes, you have to multiply this by 60 to get it in second. So that would be 150 seconds. And so we have the amps, we have the time, and the question is how much charge is required to use that. So that means we're going to use again the equation I equals Q over T, and we are solving for Q, and it has to be expressed in kilocoulombs. So that means I times Q times T divided by 1000, because you have to make it in kilocoulombs. So after calculations, we would end up with, if you check your calculation, the answer for this calculation is 1.17 kc, kilocoulombs. Okay, that's it for this section.